Alright, welcome back. In this video, we're going to go over steps 3 and 4 in gluconeogenesis. So in the last video, we ended with step 2. And the molecule we ended up with was phosphoenolpyruvate. So now we're going to start with that in step 3. So gluconeogenesis and glycolysis are actually very similar. Almost all the steps are the same. There are a few key differences though. And we're going to see 2 of those differences in this video. So let's begin. So we have phosphoenolpyruvate right here. And here's what we're going to do. We're going to use the enzyme enolase. And this enolase enzyme is going to destroy the pyruvate, deconstruct it. At the same time, we are going to add water. Now water is very important here. Think about water as composed of an OH group and a hydrogen. Because we have 2 H's and 1 O. 1 oxygen. So that's basically a hydroxyl group and a proton, essentially. Here's what we're going to do. We are going to take the OH from the water, so the water is basically a breakup, and the OH is going to go to carbon number 3 right here. So you see we have added the OH here. Now the hydrogen that's left over is going to go to carbon number 2. At the same time, for this all to actually happen, this double bond needs to break. And you can see that here. Now we just have a single bond. And essentially what's happening is this double bond here is helping create that bond between the OH and the carbon. That's basically what's happening. So now we just have single bonds everywhere. And the OH is now on carbon number 3. And the proton, or hydrogen technically, is in carbon number 2 now. So it's pretty straightforward. The difference is from glycolysis is that we're not putting in water. Gluconeogenesis, we're putting in water to actually achieve the OH and hydrogen. So, pretty straightforward. Step 4 now. Here's what we're going to do in step 4. I should say this first. Glycolysis. Around this step, we went over a histidine molecule. And what this histidine molecule did was help rearrange the phosphate groups. That was glycolysis. In gluconeogenesis, there is no histidine molecule. It's gone, doesn't exist. But what's very nice is we're going to use an enzyme to actually make this happen. This enzyme is called phosphoglycerate mutase. So it's kind of mutating the molecule a little bit. And all we're going to do is we're going to change the positions of the hydroxide group and the phosphate group. We're going to switch places. So the phosphate was originally on carbon number 2 here. That's why it's called 2-phosphoglycerate. But now we're using this enzyme, this phosphoglycerate mutase. We're going to take that phosphate and move it to the carbon number 3 position, right here. That means that the OH that was on carbon number 3 must now be on carbon number 2 here. So we just swap places. It's pretty straightforward. So yes, there's no histidine molecule like glycolysis. That's one of the key differences. We're actually using an enzyme here called phosphoglycerate mutase. So it's pretty easy. And that is it for this video. If you found this video helpful, please like and subscribe. Until next time, later.